Good morning, everyone. I switched to a different microphone because you told me that there's a little bit of disturbance, and I did see that is pretty distracting. Thank you for letting me know. We have solved problems so far from torque. We have done problems on moment of inertia. I also showed you some problems on rotational equilibrium. So at this point, I would ask you to pick up a book like HCV or Cengage, some kind of book that you prefer, and start practicing those questions. Today's class is about rolling motion. So the motion of an object when it is translating as well as rotating at the same time. After this, there's only one more topic in this chapter we have left to do, which is angular momentum and problems on rotational collisions. That's a big topic, but that's the remaining part of this chapter. In today's class, we start doing rolling motion. Okay. So what is rolling motion? When an object is moving as well as rotating at the same time, then the object can roll. So essentially, let's take an object, let's take a block and let's put it on a table. If this entire block is simply moving forward, that motion is called as translation. If you remember on the first day, we classified motion into two types, translation as well as rotation. So when something is kept on a table like a block and you're moving it forward, that motion is called as translation. You can also take the same block and you can try to spin it, kind of like tossing a copy on a table. So the block can also rotate at the same time. So an object can translate as well as rotate. It can translate and rotate simultaneously. So I made this point clear when I was teaching you this chapter. I was teaching you the first lecture in this chapter that motion is of two types. There is translation when the entire object is moving in one particular way. And there is also rotation when different parts of the object are moving differently. And if you throw a copy on a table or something like that, then the copy is sliding as well as rotating at the same time. So that is translation simultaneously, also rotation. Now consider a wheel. So if you take a wheel and you rotate, you make it move on a surface, then we know that the wheel starts rolling on that surface. Okay, so to talk about rolling, let us say that the brakes have been applied and the top of the wheel, the middle of the wheel, the axle of the wheel, and the bottom of the wheel are moving simultaneously forward. So after some time, if you take 3 points on the wheel, A, B, and C, you put some color on that, then the entire wheel is going to end up a little bit ahead. This will be C, that will be B, and this will be A. And we call this motion slipping or pure sliding. Okay, so this is called as sliding motion. The wheel is sliding. In other words, the entire wheel is basically translating forward. But if you put a wheel on a surface and you make it move in a way like this, you make it rotate as well as you make it translate. So I'll draw translate in slightly a different color. So let us say the entire wheel is translating with a speed of v. Okay, so all points on the wheel have the same speed v. So v is your translational speed. In addition to that, you make it rotate in such a way that each point on the wheel has an additional speed because of the rotation. So this point is going to have a speed of r omega because of the rotation. Because of rotation, this point stays at rest because this is the axle. And because of rotation, this point has a speed of r omega in the backward direction. Now let us say that v is equal to r omega, which means that this point is going to stay at rest. And such kind of a motion is called as rolling motion. Okay. So a motion in which the point of contact with a surface stays at rest is called as rolling motion. The point of contact with a surface, the point of contact of an object, okay, of the object with the surface is at rest with respect to the surface. Such kind of a motion is called as rolling motion. So there are two kinds of motion. There is motion that is either rolling which is what people call pure rolling, or there is motion that is not rolling, so which includes all other kinds of motion. So if an object is moving a little bit, it is sliding, it is doing whatever it is, then that is not rolling. If it is moving in such a way that the point of contact with the surface stays at rest with the surface, then such kind of a motion is called as rolling or pure rolling. Okay, understood? Let's take an example. Let us say that there is a surface, there is a road, and on this road, there is a wheel that is placed, and then somebody kicks the wheel so that the wheel starts rolling. The wheel is moving with the speed of v, and the radius of the wheel is r. So after a kick, this wheel starts rolling. Find the angular velocity of the wheel. Find the angular velocity of the wheel. So the first part of this question is find the angular velocity of the wheel. The second part of this question is find the velocity of a few points. So find the velocity of A, find the velocity of the center of the wheel, and find the velocity of the point of contact, which I'm calling S. So find the velocity of the top part of the wheel, which I'm calling T, not A, T. So find the velocity, or even you can call it the speed. Find the velocity of the top of the wheel, the center of the wheel, and the point of the wheel that is in contact with the surface. So I've called it T, C, and S. First of all, we need to find out omega. So from the definition of rolling motion, every point in this object has two velocities. So the top of the object has a velocity of v because the object is translating with the speed of v. Even the bottom of the object has a speed of v. So all of these points have a speed of v. But because the object is also rotating, so because of the rotational motion, they have some additional speed. So this speed is r omega. The bottom part of the object is going to have a speed of r omega in this direction, and the center of the object is going to have no speed because of the rotation. So keep in mind, every point on this object, every point on the object has two different speeds, has two velocities. Not two different velocities, but it has two velocities that combine together. Okay, these velocities they combine. So one velocity is because of translation. That component of the velocity you can say is because of the translation, and the other one is because of the rotational motion of the object. So different points are going to have different velocities, and that is because of the rotation of the object. Okay, so this is not only because of rolling. This is whenever an object is translating as well as rotating, this thing is true. So this is true when something is translating as well as rotating. So rolling motion is a special case of translation plus rotation. It's a special case where the point of contact, it is a special case where the point of contact with the surface has zero velocity. The point of contact with the surface has zero velocity. So when the point of contact is zero velocity, what is zero? The total velocity of that point of contact is zero. So what velocities does the point of contact have? It has a velocity of v in the forward direction. It has a velocity of r omega in the backward direction because of rolling. So v is because of translation, and r omega is because of rotation. So the total is equal to zero. So you can write plus v minus r omega is equal to zero, or v is equal to r omega. This is called as the equation of rolling motion. So you cannot always say that v is equal to r omega is the equation of rolling motion, but in this case, v is equal to r omega, or in all simple cases, v is equal to r omega. So it might immediately like remind you of A is equal to R alpha. So yes, all of those motions, the pulley or the string or something or the other was rolling. It was moving without sliding. Okay. So all kinds of such motion is represented by this simple equation. So whenever something is moving without slipping, so we call that thing rolling motion. To move without slipping. To move without slipping. Now, if you imagine slipping, when somebody slips on the floor, their feet, it slides on the floor. So the velocity of their feet with respect to the floor is not equal to zero. which is a pretty absurd way to say it, but that is exactly scientifically what rolling motion is about. If the point of contact with respect to a surface has zero velocity with respect to that surface, ठीक है, जितने velocity से surface move कर रहा है, mostly the surface is at rest, then the point of contact should also have the same velocity. It should also be at rest. In such a case, the motion is called as rolling motion. So this problem kind of explains it to you. Now the question is, what is the velocity of point T and what is the velocity of point C? There are two other points जिसका हमें velocity. So you draw your entire wheel. I've enlarged it over here. This point has a velocity of v, and we have already found out that this point has zero velocity. So how is it zero? The velocity of every point on the wheel is first of all v, because the object is translating, because the object is also rotating. So these points have an additional velocity. So the bottom point has a velocity of r omega in the backward direction, and the top point has a velocity of r omega in the forward direction. The middle point, which is kind of the axle, has zero velocity because of rotation. It has a velocity of v, but because of rotation, its additional velocity is zero. Then we also said, because this entire object is moving on a, I got disconnected twice. Anyway, let's try to do the entire thing again. I'm saying that there is a wheel that's rolling on a surface. Okay. So the midpoint of the wheel has a velocity of v in the forward direction. The midpoint has a velocity of v in the forward direction. The top of the wheel has a velocity also of v in the forward direction. In fact, even the bottom point has a velocity in the forward direction because the entire wheel is translating. Okay. In addition to moving forward, the wheel is also rotating. So these points have an additional velocity of r omega. Now we have already proved that v is equal to r omega because the object is rolling. Okay, so v is equal to r omega because of rolling motion. Because the point of contact with the surface is at rest. So that is because of rolling motion. The question is, what is the velocity of the top point and the center point? For the center point, it's kind of easy. Because of rolling, its additional velocity is zero. So the velocity of the center point is simply equal to v. What is the velocity of the top point? So that is equal to r omega plus v. So which is equal to v, because r omega is equal to v. So that is equal to v plus v, that is equal to 2v. So at this point, ask yourself if you understood this idea. V is equal to r omega because the point of contact with the surface is at rest with respect to that surface, which means if the surface is at rest, the point of contact is also at rest. इसको हम लोग कहते हैं rolling motion. So before I go forward and I start showing you problems, keep in mind that rolling motion is a sum of two things. When something is rolling on the ground, it is represented by this kind of a figure. Then that means two things. The entire object is translating. All points on the object are moving with the same velocity. In addition to that, the entire object is also rotating. So different points on the object have different velocities. The center one has velocity zero. Otherwise, different points have different velocities. So keep in mind that rolling is a sum total of translation, a vector sum total of translation as well as rotation. Okay. So when object is translating, it is also rotating, then rolling motion is possible. If an object is purely translating, rolling motion is not possible. If an object is purely rotating, again rolling motion is not possible. Even if an object is translating and rotating, if the two motions are not perfectly balanced in such a way that the point of contact is at rest, even then rolling motion is not possible. So initially to the beginning of this chapter, to this topic, we'll take a few, we'll take a few simple problems and we'll try to explore rolling motion from that. Let us say, okay, let us say that there is a surface over here. There is a surface over here and there is a roller kept between them. There is a roller that is kept between. You understand rollers, right? Ball bearings. Or for example, you take a copy and you put a few pens under it. So if you move the copy is going to slide very quickly. So we're going to talk about that kind of motion over here. All surfaces are rough, so there is friction, but we are not going to solve and find out acceleration, so don't bother about the force. Let us say that this top surface is moving with the speed of v. The top surface is moving with the speed of v. What is the velocity of the center point? What is the velocity of the center? What is the velocity of the point in contact? So what is the velocity of Vs? And what is the angular velocity of this roller if its radius is equal to r? Okay, so that's the problem. Assuming that the roller is in rolling motion, it's a roller, so it is rolling on both the surfaces. There is rolling motion on both the surfaces. So how do you solve a problem like this? First of all, the definition of rolling is that at any point of contact, so at this point of contact and at this point of contact, the velocity should exactly match the velocity of the surface. So the velocity of the body minus the velocity of the surface should be equal to zero. So the velocity of the body with respect to the surface is equal to zero. Now mathematically writing this equation might seem a little bit scary to you, but it is kind of very simple. If the surface is moving at some speed, the object should also move at the same speed. So basically the velocity at the top point should be equal to v because this top object is moving with the speed of v. So velocity at the top point is v. What is the velocity at the bottom point? My floor is at rest. I did not say that the floor is moving, so my floor is at rest. So the bottom point on the object should also be at rest. So Vs is equal to 0. The velocity of the bottom point should be equal to 0. Okay, the surface is at rest. So the bottom point of the object should also have 0 velocity. So these are the two constraints, one on the top, one on the bottom. Now let us say the velocity of the center point is equal to x. Let us say the angular velocity is equal to omega. So because the velocity of the center point is equal to x, all points, I'm going to draw these in like these in red. So all points on the object, the top point is going to have a speed of x. The middle point of this object is going to have a speed of x. Even the bottom point of this object is going to have a speed of x. Because the object is moving with an angular velocity of omega, I'm going to draw this in green. The top point is going to have a speed of r omega because of rotation. The center point is not going to have any speed because of rotation. And the bottom point is going to have a speed of r omega in the backward direction because of rotation. So each point has two different speeds. It has a speed of r omega because of the rotation. It has a speed of x because of the translation. So the velocity of any point, the velocity of any point is the velocity because of its translational motion plus the velocity because of its rotational motion. That is because the object is rolling. Whenever something is rolling, there is translation and there is rotation. Okay. So now let's go to the top. So at the top point, the speed of rotation is x. In addition to that, the speed of translation is x. In addition to that, the speed of rolling or the speed of rotation is equal to r omega. तो ट्रांसलेशन की वजह से उसका स्पीड x है और रोटेशन की वजह से उसका स्पीड कितना है r ओमेगा है. तो इन दोनों का जो सम है that should be equal to v. That's because the velocity of the top point is v. Now at the bottom point, the velocity of the bottom point is 0. So what do we have? We have x in the forward direction, but we have r omega in the backward direction. So x minus r omega should be equal to 0. That is because the velocity of the bottom point is 0. Okay, so these are equations. So you will write x is equal to r omega. We kind of expected this. So x is equal to r omega. Now you take this and you put it over here. So you will get 2x is equal to v, which means x is equal to v divided by 2. समझ में आया? You got this? So everything on the screen is vanished because once again I got disconnected. I don't know why that keeps happening today in today's lecture. So at least I said that x plus r omega is equal to v at the top point, and at the bottom point x minus r omega is equal to 0. So basically x is equal to r omega. If you substitute that over here, then you'll get that 2x is equal to v, which implies x is equal to v by 2. Now when x is equal to v by 2, we can again put that in this equation over here to get v by 2 is equal to r omega, which means omega is equal to v divided by 2r. The question I asked you is that there is a roller between two surfaces. The bottom surface is at rest. This surface is not sliding, and the top surface is moving with a speed of v. The question I asked you is what is the speed of the center and what is the angular velocity of this roller if it is rolling? So let the angular velocity is x, let the angular velocity is omega, let the velocity of the center is x. So what we did is we found out the velocity of the top point and the bottom point, that is x plus r omega and x minus r omega. And then we said because it is rolling, then at every point of contact, the velocity with respect to the surface has to be equal to zero. Okay. So because the velocity with the surface is equal to zero, so here the surface is at rest. So this point should also be at rest. Velocity with respect to surface is equal to zero का मतलब ये है कि velocity of body is equal to velocity of surface. So velocity of body is equal to velocity of the surface at point of contact. Basically यही rolling का condition है, at point of contact. This is the condition of rolling. ठीक है, दिस इज द कंडीशन. तो मैं इसी कंडीशन को अप्लाई करना है. तो ऊपर सरफेस का वेलोसिटी v है, which means that because the surface is moving at v, this point should also move at a speed of v. ठीक है. तो वीडियो एक दो बार डिस्कनेक्ट हो गया तो मे बी यू माइट हैव लाइक लॉस्ट द कंटिन्यूटी, बट दिस इज हाउ इट इज. लेट्स ट्राई अनदर प्रॉब्लम ऑफ एग्जैक्टली द सेम टाइप. Take a surface. Okay, so on this surface there is a very big roller which has a smaller kind of a groove inside it. So the radius of this groove is equal to r by 2 and the radius of the roller is equal to r. So on this groove, there is a plank that is sliding. So there is a plank that is kept on this groove and this plank can slide. So this plank can move. Now it is known that the velocity of this roller is v. The velocity of the roller is v. So you have to find out what is the angular velocity of the roller, what is omega, and what is the velocity of this plank. इस plank का velocity क्या है? So it is given that the roller is rolling. You need to find out the velocity of the plank if the velocity of the roller is equal to v. How do you solve this problem? Now let us say the velocity of the plank is v plank. What are the points of contact? This is a point of contact. This is a point of contact. So if the roller has a speed of v, then at this point of contact, even at the top of the roller, even at the bottom of the roller, all of these points are moving forward with a speed of v. So this point is also moving forward with the speed of v. That point is also moving forward with the speed of v. Everything is moving at a speed of v because the entire roller is translating. In addition to this, the roller is also rotating. So because it is rotating, because of the rotational motion, this is going to have a speed of r omega. This point is going to have a speed of r divided by 2 omega. And this bottom point is going to have a speed in the backward direction of r omega. Why? Because this entire thing is rotating. Whom right is it is rotating. Because it is rolling on a surface and the velocity of the surface is equal to zero. So the velocity of this point on the roller also has to be zero. So what is the velocity of that point? It is v in the forward direction. It is r omega in the backward direction. And the total value has to be equal to zero. Okay, because it is rolling on that surface. The velocity of the object is equal to velocity of the surface. The velocity of the body is equal to velocity of the surface. So what is the velocity of my surface? Zero. So the velocity of the body at this point has to be equal to zero. If this thing kind of feels a little bit weird to you, take a pen. Okay, you take a pen and you put the pen on a surface so that its tip is touching. So if you try to push the pen with your fingers, then the entire pen is going to rotate, but the tip can stay at rest. Even if this point is at rest, the rest of the pen is moving. This is exactly the idea of rolling motion. So, okay, don't start getting confused that if the object is if the object is moving, then how is a point on the object at rest? That is how rotational motion is. Different parts of the object can have different velocities. That is the entire idea of rotational motion. So the point of contact of the object with the surface is zero. It is at rest because the surface is at rest. So you can say that V is equal to R omega or omega is equal to V divided by R. First equation, we found out the value of omega. Omega is equal to V by R. Okay. So what is the velocity of the object at this point? The velocity of the object at this point is equal to V because it is translating. it is also equal to r by 2 omega, r divided by 2 omega. This is the velocity of the body. What is the velocity of the surface? What is the surface? The surface is a plank. So what is the velocity of the plank? V plank. So both of them have to be equal because it is rotational motion. This is rolling motion. So rolling motion का condition क्या है? Velocity of the body has to be equal to the velocity of the surface at the point of contact. At the point of contact. तो यहाँ पे कांटेक्ट हो रहा है, दोनों की वेलोसिटी सेम है, ओमेगा का वैल्यू कितना है, v बाई आर है, तो v प्लस आर बाई टू इंटू वी डिवाइडेड बाई आर. How much is this? R is going to cancel, so velocity of the plank is going to be equal to v plus v by 2, which is equal to 3v by 2. So the velocity of the plank in this condition is equal to 3v by 2. समझ में आ रहा है रोलिंग मोशन क्या होता है? इट हैज टू डिफरेंट वेलोसिटीज, एक तो ट्रांसलेशन का वेलोसिटी और दूसरा रोटेशन का वेलोसिटी. सो रोलिंग इज ट्रांसलेशन प्लस रोटेशन, लेकिन सिंक में. Try another one. Get these questions, try to understand what I'm saying through these questions, and then you can apply it to a problem. So there is an object that is rolling, which means that it is translating as well as rotating at the same time. This time I'm going to ask you, what is the velocity of the front and the back of this object? So the center of this object has a speed of v in the forward direction. The radius of this object is equal to r. The object is rolling with some angular speed omega. Because it is rolling on a surface, so obviously the bottom point of this object has zero speed. This point is at rest. ठीक है, ये point rest पे है. तो मैं ये पूछा जा रहा है कि front of the object and back of the object का speed क्या होगा? What is the speed of the front of the object? What is the speed of the back of the object? So before you start solving this problem, always draw this kind of a diagram where you say that every point on the object is going to have the same speed because the object is translating. Whenever something is rolling, then it is automatically translating. But whenever something is translating, it is not essential that it is rolling. तो अगर कोई ऑब्जेक्ट रोल कर रहा है तो पक्का वो ट्रांसलेट कर रहा है, लेकिन अगर कोई ऑब्जेक्ट ट्रांसलेट कर रहा है तो इट इज नॉट एसेंशियल कि इट इज रोलिंग, इट वुड आल्सो बी स्लाइडिंग. So, like, just think of a car, the wheels in a car. When the car is moving forward, all the wheels are like, they are rolling on the road. Okay, like, and suddenly you apply the brakes, all the wheels are going to lock, but immediately the car won't stop. So the wheels are going to keep skidding on the road until the car stops. So there is translation, but there is no rotation. So keep this logic in your head. This is V of all the points. Now the object is also rotating. So this point is going to have a speed of r omega. This point is going to have zero speed because of rotation. This point is going to have a speed in the downward direction. This point is going to have a speed in the backward direction. And this point is going to have a speed in the upward direction. समझ में आया? इसका नीचे होगा, इसका ऊपर होगा, because the entire thing is going to roll. It is going to rotate. Now the velocity of the point in contact with the surface is equal to zero because the surface has zero speed. So V body is equal to V surface. That is because something is rolling. So you would say that plus V minus R omega is equal to zero. क्योंकि velocity of the surface is at rest, the surface is at rest, तो उसका speed zero. So V is equal to R omega. पहला equation. Now we wanted to find out the velocity of the front. So at the front there are two speeds. एक तो रोलिंग का स्पीड है नीचे के डायरेक्शन में, और दूसरा इसके ट्रांसलेशन का स्पीड है फॉरवर्ड डायरेक्शन में. So what is the velocity of that point? It is the net velocity, V net. How much? V square plus R omega square का root over. What is the angle? The angle is equal to theta. So first of all, let's find theta. So tan theta is equal to the perpendicular, which is equal to r omega, divided by the base, which is equal to v. But r omega is equal to v, so this is equal to 1. So theta is equal to 45 degrees. So at the front of the object, the velocity is directed at 45 degrees downwards. And at the back of the object, like you can easily discover, the velocity at the back of the object is inclined at 45 degrees in this direction. So this angle is equal to 45. Yes. At the back of the object, as you can see, the velocity is forward. This is upward. They are both equal to each other. So this angle over here is equal to 45 degrees. So यहाँ पे the angle is 45 degrees downward. यहाँ पे the angle is 45 degrees upward. ठीक है, समझ में आया? तो v square plus r omega का square. तो what is v का square? V square. What is r omega? That is also v square. So ये हो जाएगा v root 2. The velocity of the front of the velocity of the front point of the tire is equal to v root 2. What is the velocity of the back point? So at the back point, the velocity is v towards the forward direction. It is r omega in the upward direction. So the net velocity is again equal to v root 2, but in this direction, 45 degrees upward. समझ में आ रहा है? How you're able to calculate velocity of different points where an object is rolling. So I think you've gathered enough practice. Now I'll ask you a question. Pause the video and you give it a try on your own. Let us say there are two planks that are moving in opposite directions. So this plank is moving forward, that plank is moving backward. There are two planks that are moving in opposite directions. Let us say the velocity of this plank is equal to 3v and the velocity of this plank is equal to 5v. Between them, there is a roller that is rolling. So this roller has rolling motion. Okay. So I'm asking you, what is the angular velocity of this roller? So that is omega, find out the value of omega. And what is the velocity of the center of this roller? So what is the center? So you should pause the video right now. You should give it a try and come back once you're done. The method of solving is obviously the same. You take a top point, you take a top point P, take a bottom point. I normally call it S, but you can call it anything you want. You can call it A and B also, much better. A is the top point, B is the bottom point. Okay, top and bottom. And C is the center point. Okay, so let's do that. Let's call this point B for bottom, and let's call T for top. B for bottom, T for top, and C for the center. So क्या करना है? At every point of contact, at every point of contact, the velocity of the object should be equal to the velocity of the surface. So velocity of the body should exactly match the velocity of the surface because the object is in rolling motion. तो इस चीज को अप्लाई करो. Pause the video right now, apply this thing, see if you get the answer, and then you can play it. So I would do exactly this. So what is the velocity of the body? The body is executing two kinds of motion. Let's say the velocity of the center is like, vc. So this point is going to have a speed of vc. Even the bottom point is also going to have a speed of vc. The object is also rolling, so it is going to rotate. So this point is going to have a speed of r omega, and the bottom point of this object is also going to have a speed of r omega. Now at the top as well as at the bottom, the velocity of the object should be equal to the velocity of the surface. So what is the velocity of the surface at the top? So at top, what is the velocity of the surface? 3v. What is the velocity of the body? Velocity of the center plus velocity of rotation. First equation. At the bottom point, at bottom. The bottom point way, what is the velocity of the surface? The velocity of the surface is equal to 5v. So just notice that whichever direction the object is moving, I'm taking that direction as positive. So velocity at the bottom point is equal to 5v. So 5v कितना हो जाएगा? It will be equal to r omega because r omega is in the same direction. So that is r omega. But it is vc is in the opposite direction. So you'll write r omega minus vc. So that is the second equation. Now I have to somehow solve both of these equations to find out vc as well as r omega. First of all, I notice that if I subtract these equations, I can easily find out the value of Vc. So I'll get Vc, 2Vc, 3V, 5V, minus 2V. So Vc is equal to minus V. What does that mean? It means that we were assuming the roller is going to move forward, but actually the roller is going to move backward with the speed of V. Okay. So the minus means that our assumption was wrong. It's going to move in the opposite direction. We were assuming it will move towards the right, but actually it is going to move towards the left. So we are getting minus v, leftwards with a speed of v. Now you add both of these equations to get the value of r omega. So you'll get 2r omega is equal to 8v. So r omega is equal to 4v, or omega is equal to 4v divided by. So why v is not equal to r omega? That is because v is equal to r omega when an object is rolling on a surface at rest. Always not v is not equal to r omega. Okay, so if you take an object that is rolling on any surface, you won't get v is equal to r omega. It is only true when an object is rolling on a simple surface at rest, the simplest possible condition. In all other conditions, this is exactly what I want to teach you in today's class. You have to write equations to find out the condition of rolling. So in this case, our object, our roller, is actually moving backwards with a speed of v, and the angular velocity of this roller is equal to 4v by r, and the angular velocity is in the direction that we assume. So it is moving backwards, but it is rotating in this direction. Okay, so this is the rolling motion that is happening. Now, once you have understood this, try another problem. But I would suggest that if you could not solve it, you go back and you try solving this problem once again. The condition of rolling is that the velocity of the body is equal to the velocity of the surface. ठीक है, समझ में आया? एक और ट्राई करते हैं. Let us say that there are two pulleys. Okay, there are two pulleys. There is a small one, a smaller pulley of, let's say, a radius of 2r, and there is a much larger pulley over here. Okay, and let us say its radius is equal to 4r. And on these pulleys, there is a belt that is passing. So this belt wraps all around this pulley. It comes back to the smaller pulley, and then it continues. So these pulleys, they are joined together by a belt. Now this belt is moving with a speed of v. The velocity of the belt is equal to v. So can you tell what is the angular velocity of each pulley? What is omega 1 and what is omega 2? And what is the relation between omega 1 and omega 2? So what is omega 1 and omega 2 ka ratio? What is omega 2 divided by omega 1? First of all, understand that this belt is not slipping. This belt is not slipping on each pulley. That is how the pulley is rotating. It is not slipping. So जितना बेल्ट का वेलोसिटी है उतना पुली का भी वेलोसिटी होगा. Is the pulley translating? No, the pulley is not translating. So all points on the pulley have zero velocity because of translation. But because of rotation, they have some amount of velocity. So that is 4r omega 1. Now this velocity has to be equal to the velocity of the surface on which it is not slipping. So what is it not slipping on? It is not slipping on this belt. So what is the velocity of the belt? V. What is the velocity of a point on this pulley? 4r omega 1. So what is the velocity of that pulley? The angular velocity? V by 4r. In exactly the same way, you would write 2r omega 2 is equal to V, which means omega 2 is equal to V by 2r. Now you want to find out omega 2 divided by omega 1. So what is omega 2? V divided by 2r. What is omega 1? V divided by 4r. So if you divide it, the ratio is equal to 2. समझ में आया? This is the case of rolling motion. So in this case, something is not rolling and going ahead. So it would be more correct to call this kind of motion slipping. Okay. So it is not slipping. That is the exact thing that we say. The rope is not slipping on the pulley. So we wouldn't call this slipping motion. We would say that the rope is not sliding on the pulley. We won't say that the pulley is rolling because it is not rolling on a surface. Rather, the right thing to say is that the rope is not slipping on the pulley. So because of that, the angular velocity of each pulley is omega 1 and omega 2. Why is omega 1 not equal to omega 2? Because the sizes of the pulleys are different. Okay, so this is another problem. There are many different problems. You can try as many of them as you want. Let's take another one. Let us say that there is an object that is rolling down an inclined plane. There is an object that is rolling down an inclined plane. So this object is coming down an inclined plane. So if the acceleration of this object is a, if the acceleration of this object is a, what is its angular acceleration if the radius is r? So let the angular acceleration be equal to alpha. The inclined plane is at rest. So this point on the inclined plane is at rest. So at this point, the object has a linear acceleration of a, but because it is rolling or because it is rotating, its backward acceleration is r alpha. So we can say plus a minus r alpha is equal to 0, or a is equal to r alpha. because the object is rolling. Okay, so that's the condition for rolling. So in this way, there are several different problems that are solved based on this concept. So the first thing today was all about rolling motion. We will encounter rolling when we solve further problems in rotational motion. So one of the problems I want to teach you today, once you're very confident with the concept of rolling, is this problem when an object is rolling down an inclined plane. So if an object is rolling down an inclined plane, what is the acceleration of the object? So let's remove all the unnecessary things in this figure. And let's first of all frame the question. Find the acceleration of an object. Find the acceleration of an object which is rolling down an inclined plane. Which is rolling down an inclined plane. Which is rolling down an inclined plane. So I first of all derived the condition for rolling, that A is equal to R alpha. The next thing to do to solve this question is to draw all the forces that are acting over here. So what forces are acting? There is mg that is acting in the downward direction. There is normal force that is acting in the upward direction. And whenever there are any two surfaces in contact, there is friction. Now the question is friction required for rolling motion? See, once one object is moving, so all points on this object have to move in the forward direction. Even then, one point on this object is at rest. So there has to be a force that is preventing that point from moving, which is why it is at rest. So friction is required for rolling motion. Friction is required for rolling motion. This is kind of obvious. It is kind of a common sense kind of thing. If something is very smooth, then you would slip on that surface. You cannot walk. You cannot make a wheel rotate. So on that surface, if you start a car, the wheel is going to start skidding. It is going to keep moving in one place. So if the surface is rough, only then you can have rolling motion. So friction is required for rolling motion. Let us say the friction is equal to F. We'll talk in detail about this in just a minute. Right now, let us assume that the friction is equal to F. So why is the object moving down? As always, the object is moving down because of this angle theta. Okay, so the component of gravity in this direction is mg sine theta. That is the component because of which the object is rolling down. It is not moving because of mg cos theta, but because of mg cos theta, it is resting on this surface. So if you remove mg cos theta, the object will start flying. If you remove mg sine theta, the object is not going to move forward. So mg sine theta is responsible for the move, like the translational motion, and mg cos theta. Sorry, mg cos theta is responsible for the object staying on that surface. Okay, so plus mg sine theta minus f is equal to ma. Writing the equation in this direction, plus mg sine theta minus f, because the friction force is acting in the opposite direction. So plus mg sine theta minus f is equal to ma. The normal force and the mg cos theta, they balance each other. So you can write that equation, plus n minus mg cos theta is equal to 0. But because this equation is not relevant, it's not responsible for the motion of anything in this problem, it's not relevant. Why is the object rolling? Why is the object rotating? It is rotating because the friction is producing a torque on this object. The friction is acting on the surface of this object and it is producing a torque. So what is the torque produced by friction? R into F. See, take the center of mass as the axis. Whenever something is moving, or in general, always take the center of mass as the axis. About the center of mass, the torque of friction is in the same direction as rotation. So you can write plus Rf is equal to I times alpha, which is your third equation. Now we need to find out A. So one thing we can do is we can find out the value of F. So F is equal to I divided by R. We can also substitute alpha. So alpha is equal to how much? Alpha is equal to A divided by R. So I into A divided by R. And then we can put this value of F in the first equation. So writing on the left side, mg sine theta minus, instead of F, you write I divided by R square into A is equal to MA. Or A into m plus I by r square is equal to mg sine theta. So what is the value of A? A is equal to mg sine theta, okay, divided by m plus I by r square. So whenever an object is rolling down an inclined plane, the acceleration of that object is given by mg sine theta divided by m plus I divided by r square. इसका मतलब क्या है? So to find out the meaning of this thing, you can come back to this slide again and you can try to understand the derivation. In simple terms, what I did was I wrote down all the forces. I first of all wrote down the condition of rolling. Secondly, from all the forces, I wrote down three equations out of which two are essential towards the rolling of towards the motion of this thing. So MA is for translational motion and I alpha is for rotational motion. So and then I solved those equations and I found out the value of A. The question is, what does A mean? So A is equal to mg sine theta. So I'm going to remove the m from the numerator. I'll just write g sine theta divided by 1 plus I by mr square. So A depends on I by mr square because g sine theta is a constant. So what is I? I is equal to some number into mr square. You must have noticed this by now. For a ring, it is equal to 1 mr square. For a disk, it is equal to half mr square. For a sphere, it is equal to 2 by 5 mr square. For a shell, it is equal to 2 by 3 mr square. So for something, it is equal to k mr square, or it is equal to n mr square. So in general, we can write for something, this value is equal to k mr square. So if you divide I with mr square, so you will only get the value of k. So the acceleration of an object is equal to g sine theta divided by 1 plus k. So this just basically means that it depends only on the shape of an object, only on shape. Okay. So if the object is a cylinder or if it is a sphere or it is a shell, that matters. The mass of the object and the radius of the object will normally not matter. So even if you have a cylinder and the moment of inertia is equal to mr square for some reason because the mass distribution is not uniform, then that's a different story. But as long as an object is uniform, the density of the object is uniform, then it only depends on the shape of an object. So one question that's usually asked in JEE mains is that if you take a ring, you take a disc, you take a sphere, so you take a ball, and you take a hollow ball, so you take a shell, and they are rolled down an inclined plane, which of these, which of these is going to have the highest acceleration? Which of them is going to have the highest acceleration? So the acceleration is inversely proportional to the value in the denominator. So for a ring, this value is going to be 1 plus 1, 2. For a disk, this value is going to be 1 plus 1 by 2, which is 3 by 2. For a sphere, this value is 1 plus 2 by 5, 7 by 5. For a shell, 1 plus 2 by 3, which is equal to 5 by 3. So which is the highest value? 2. The acceleration is inversely proportional. So this has the slowest acceleration. And which is the least value? What is the value of 7 by 5? 7 by 5 is obviously greater than 1. 3 by 2 is equal to 1.5. 7 by 5 is equal to 1.4. And 5 by 3, so 3 ones are 3, 1.66 something. Okay. So the least value over here is equal to 1 by 4. So the sphere is going to have the highest acceleration of all of them. So first of all, you will have sphere, the highest acceleration. Then next to that, you will have your disk. So acceleration of the disk is next highest. Then you have 5 by 3, which is 1, 2 by 3. Then you have shell. So the next thing is acceleration of the shell. So acceleration of the sphere is 1.4. Acceleration of the disk is 1.5. Acceleration of the shell is actually 1.66, 1.7. And then finally, you will have acceleration of a ring. So the ring is going to be the slowest to roll down, and the sphere is going to be the fastest to roll down from an inclined plane. Okay. So I hope you understood this problem. This is a basic application of rolling. There are other equations or there are other problems where this concept is used, but this is the simplest one, which also has a direct question in JEE. Okay. So coming back once again to talk about this problem, what do I do or what do you do when you solve a problem like this? First of all, you draw the object. Okay. Then neatly you mark out the acceleration as well as the angular acceleration, so which is a and alpha. Then you take the point of contact and you say that the velocity of the object has to be equal to the velocity of the surface. And then you write velocity of the object is equal to a in the forward direction or alpha in the backward direction. So keep in account both of it, and then you write velocity at the surface is equal to 0. So you can write a is equal to r alpha. This is the rolling equation. And next to that, you draw all the forces. So here you have normal force, then you have mg in the downward direction, and then you have friction in the backward direction. So you draw all the forces. You write down an equation for each direction of motion. So you will write down an equation for the horizontal motion of this object, this inclined motion. And you will also write an equation for the rotational motion of the object. So you'll write an equation for both of those kinds of motion, and then you would solve it. समझ में आया? So that's it for today's class. Tomorrow we'll solve more problems on rolling motion. Try to understand rolling on your own. See you tomorrow.